Hey there. This week we're doing something a little different than last week. Last week we were doing three-dimensional objects, finding the volume. This week we're looking still at three-dimensional objects, but now we're looking at what is known as the surface area. The good news is while I was still with you at school, we already learned about area, how to find the area of triangles, don't forget to have something, and all of the quadrilaterals. We had practiced that and took our assessment and everything like that already. So remember, area is finding squares, how many squares it takes to cover that surface. Well, that's our lesson here, to cover the object. Okay, now volume wants to know how much it fills up altogether from the inside, of the room, like our classroom, all the way. Where surface area, we're only going to deal with the floor, the ceiling, and the walls. Okay, we're only going to look at the outside surface when we want the surface area. For instance, on this shape, when we did volume, we just needed the length, the width, and the height, and we multiplied those three dimensions to find out how many cubes it took to fill this thing up. Well, for us now this week, it's a little bit different. We're going to actually figure out how many squares it takes to cover the outside surface, to cover all of the six faces of this rectangular prism. What also is a little bit of a leap here is we are not going to just be using prisms. We're also going to be using pyramids. Okay, so you do need some background knowledge. I want to just make sure that we refresh this background knowledge that you should hopefully know. And if not, I want to present it to you very quickly. Prisms always are made up of rectangles on the sides or squares. Okay, so this one has four rectangles, two of them actually are squares, and the other two are rectangles, but four rectangles around the side. And the two bases on this shape are rectangles. They don't have to be, okay? So the bases can be any polygon. But for this problem, it's a rectangular prism because there are two congruent bases, the one here on the bottom and the one on the top. And then, of course, there's always going to be rectangular, or it could be even square faces. They're called lateral faces on the side, okay? The other one that we may see is also a prism, but notice the bases are literally made up of triangles, okay? So there's still two of them, just like any other prism, those two bases, but this time they're still squares. Prisms are always made up of squares, but those squares, here it looks like a square, those rectangles, are going to be only three of them, okay? There's only going to be three lateral faces for this triangular prism because it has on the bottom three sides of its base. So off of each base are going to be rectangles or squares shooting up, and those are what are called, again, the lateral faces. Okay, so triangular prism has two bases that are triangles and three faces that are rectangles. Rectangular prism has, like we've already been looking at, two bases and four more faces that are all rectangles, though some could be better classified as squares. The other thing we're going to have to encounter, of course, is the pyramids, which only have one base. Okay, so a prism has two bases always, a pyramid only has one. And this pyramid is a square pyramid because the base is a square. So whatever the name of the base is the first name of the pyramid or the prism, okay? And then the other opposite end is just a point on a pyramid. Okay, so remember, prisms have two bases, pyramids only have one, and the other side is just a point, the opposite direction here on the top. The lateral faces, instead of being rectangles like the prism, are actually made up of triangles. So pyramids are always made up of triangles as their lateral faces. How many you have depends on the name of the shape of the base. Okay, so if it's a quad, four-sided figure, there's going to be four of these triangles. Okay, if it was something like a triangular pyramid, then there would be a triangular bottom, and then there would be three triangles also on the side. There would only be four faces, so be careful. We would only want to find the area of these five faces here, and then for this one, we're going to want to find the area of these five faces, and then for this one, we'd want to find the area for six faces. And of course, sum means that you add them all together. So we're going to go back to our module 13 when we found the area of polygons. We're going to find how many squares it takes to cover it. but we're going to do it on every face of the three-dimensional object, and then we're going to add them all together at the end. Now doing this, when we get to some classwork I'll show you here in a second, there are some shortcuts. Okay, so very quick, just to make sure you understand, this is supposed to be my drawing of something like this, where it is a triangular prism. Okay, there's literally the triangular front here, and then the triangular back here, which are known as the bases. Not always on the top and bottom, depends on how you lay this thing. And then on the side, you're going to have these three rectangles. What I wanted you to see, not that I'm going to do all this work yet, just to show you that the triangles are actually congruent. This is a base of 7, and I tried to draw it out here. The height, remember it's a 90-degree angle, the base and the height, is a measure of 10 centimeters. Don't forget, I want to remind you, when you do the area of a triangle, you got to half something. So for me, I would half the 10, make it 5, and then multiply 5 and 7 is 35 centimeters squared on the front base here, okay? The back base would be the same, so there's a shortcut where you could just double that since the two areas are equal. But I did want to show you that you got to be careful. It depends on what kind of triangle the base is. So this is in more review here. Remember, we've learned that based on the sides, there's equilateral triangles where all three sides are the same. There's isosceles triangles, which is what I kind of tried to draw here, where this leg here is, this side is 11, this side's 11, but this bottom base of the triangle, side of the triangle, is 7 centimeters. So you see an 11, 11, a 7, that means that these two 11s are congruent. So I know that in my rectangles over here, this rectangle over here to the right side over here would be 11 by 9. And that's 99 centimeters squared. And then this back one also would be an 11 by 9. So if you ever see a dimension that's going in one direction and another line that looks like it's parallel to that going in the same direction, they're the same measurement. So this would be an 11 by 9 also, which is 99 centimeters squared. What I wanted to show you is the bottom of this figure down here that it's resting on is not an 11 by 9 rectangle. It's actually, if you look, a 7 by 9 rectangle. So you got to be kind of careful. So just showing, I mean, I'll show you some work in a second, but this would be to find the surface area. It's a lot of work. You have to literally say that we said this one, I believe, was 35 centimeters squared, 35 centimeters squared, 63 at the bottom centimeters squared, 99 here, another 99 here. Add all 5 of those numbers together, and now you found out how many squared units it takes to cover this object. Usually surface area deals with like painting, a wall, lying down carpet in a room. It's things like wrapping a present. So it's always covering the outside where volume is filling up on the inside. Hope that helps a little bit, just as an introduction to what we're doing. And now if you watch another video, I'll actually show you some work being done.